So we'll discuss here how to prepare your cluster machines for your grid infrastructure installation. So the idea is, yesterday the machines that we created, alpha and beta, will ensure that from all angles they are all looking good uh, prior to we invoking the installer, the grid infrastructure installer. The first thing is to verify that the operating system and the kernel versions are supported, rather are certified. The certification matrix can either be obtained from the support Oracle support website, and if not, you can go to tahiti.oracle.com. You can locate the product that you are planning to install. In our case, it's Oracle Database 11G Release 2. This takes you to the landing page of Oracle Database 11G Release 2. You can go to master book list here, and somewhere down under you will see an installation guide. I am interested in the installation guide of Oracle Database Quick Installation Guide for Linux 64-bit edition. I am clicking the HTML version of it, and in short it would talk about what is required. The first thing is, I need to check which operating system and kernel editions are certified. This is the operating system requirements. Your Linux distribution should be any one of the following: Asianux, Oracle Linux 4.7 and higher, 5.2 and higher, 5.5 is also okay, Oracle Enterprise Linux 6, or Red Hat Enterprise Linux 5.7, 5.2, 5.5, Red Hat Enterprise Linux 6, or it could be SUSE Linux 10 SP2 Service Pack 2, or SUSE Linux Enterprise Server 11. I would quickly validate against my installation. I am checking which of the versions I am using. I am using 5.4, which anyways is certified. I am using Red Hat Enterprise Linux RHEL 5.4, and we are using a 64-bit edition of Linux. The kernel version is this 2.6.18-164 Enterprise Linux, and I am checking, is it certified. 2.6.18 is certified. Whatever is the errata updates that are applied after that, they are all okay, provided your main kernel version is 2.6.18. So from the OS supportability side, it all looks good to me. So visit the official documents at tahiti.oracle.com. It's also called as docs.oracle.com, or you can also jump onto support.oracle.com and then check the official documents. Check if your OS and the kernel version requirements are met. Do not, you can try for R&D purpose at home, trying to install Oracle on Fedora, Ubuntu, whatever. But in real life, you will never install it on any of the uncertified platforms. It might still work, but then you never take a risk, because the whole product then becomes null and void for us from the support agreement perspective. So if you face some problem going forward, yours is a Ubuntu based installation. I'm not saying that it will not work, but assume that someday you are stuck, you open a ticket with Oracle support, and then they ask you which operating system platform you are running it on, and you said I am running it on the latest version of Ubuntu, then they will not entertain that ticket. So from the certification perspective, it's very important that you run it only on the certified operating system platforms. Ensure that all mandatory packages are installed. Each operating system would have certain packages which are nothing but add-on software products that one can install. Each operating system would have its own proprietary style of installing those packages. Linux treats those installable packages as RPMs, which is Red Hat Package Manager, and all those packages can then be installed one after the other depending on your OS requirement. Similar way, Sun has its own, Sun Solaris would have its own way of installing packages. Similar way, on AIX also you would have uh, their own proprietary way of installing the packages. Uh, in AIX they are called as LPPs, license program products. So depending on the operating system, you can get those packages installed with the help of your Unix admin. I am just quickly revisiting the package requirements. So here I am looking at the package requirements for 11G release 2, and if I am using Oracle Enterprise Linux or Red Hat Enterprise Linux 4, this is the package requirement. If I am on to Oracle Enterprise Linux 5 or Asianux 3, this is the package requirement. I am not going to validate each one of them because I know while installing I selected almost everything. So remember, after the boxes were installed with the operating system, the two missing packages are often seen as libio development libraries, both 32-bit and 64-bit. Those we got it installed, but just to quickly check, do I have binutils, the certified version? So I am saying rpm-q binutils, and pretty much I am using 2.17.50.0.6. Similar way, you can quickly verify your software requirements or package requirements, are they fulfilled or not. I can see both 32-bit and 64-bit editions are also there. So package side, using rpm-q query followed by the name of the package, you can validate whether or not all the packages are installed. If not, get it installed from your Unix admin, because packages might have dependencies. So I found out, let's say that 4 of the packages are missing. When I'm trying to install package 1, it says it depends on package X. When I try to install package X, it says it depends on package Y. When I try to install package Y, it says it depends on package Z, and it may be a never ending list this way. So better if you give this job to the OS guys, because they know there's a easier method of installing all the dependent packages using something called as yum update or aptitude get. So there are different ways of installing the packages depending on your Linux distribution. Similar way, in case of AIX, those people will get the installable images, INST images mounted on the AIX boxes, uh, where from they can then install by saying lslpp or install the license program products. Either ways, the point here is all the mandatory packages should be there. Now, one of the most common argument is, what if a certain package is not installed and I start with the installation? I'm saying, why to even spend energy on saying what would happen when there would be that last day, Qayamat? What will happen then? Will I get a boat or will I get a ship? Or I will be sitting on a log? Instead, why not think of positively creating an environment, which is what Oracle document says. There are multiple undocumented behaviors. Probably your relinking might fail. Probably your installer itself might not proceed, which is outside the scope of a regular discussion. Anyways, next thing is ensure that the necessary users and groups are created, and across the boxes the user IDs and the group IDs must be same. So this is the first time I'm logging on to the second machine, the second rack node. I am checking the ID details for user Oracle on both the machines, and at both the places I find it that user ID for Oracle is 500, group ID is 500, the primary group membership for Oracle user is for O install, and that for a DBA group is as the secondary group membership for Oracle user, where the GID is 500 and 501 respectively for O install and DBA. So this looks okay. If not, get those user accounts created. Remember, I said it is possible that you might go for SODs, which is separation of duties, in which case grid software can be installed as some other user, let's say OraGrid, who is a member of oinstall group, and your Oracle software, RDBMS software, can be installed as Oracle user who is primarily a member of oinstall group. Deliberately I am not talking about the secondary group ownerships, because from one person to another the choice of secondary group might vary. Typical secondary groups for Oracle user are DB and OPER, but it's not mandatory that you should have the same groups. Similar way, for grid infrastructure, it might be ASM admin and ASM operator. It depends what exactly you are trying to accomplish. However, our install is quite simple. Our install would all be done as Oracle user, because I'm not planning for separation of duties. My DBA, Oracle Database Administrator, and the ASM Administrator are going to be the same person. Then there's no point implementing them as two separate Unix accounts. In which case, I'm planning to install it as Oracle user who is a member of oinstall group primarily, and secondary group membership for that user is to the DBA group. Very important thing, often ignored aspect of cluster: ensure that the machines are time synced. Set up NTP if required. Now, the machines in the real world would always drift away from each other as far as the clock time is concerned. So if I start up two machines today with the clock, the CMOS enabled clock set to the same split second value, day, date, time, hours, minutes, seconds, century, and even split second I am saying, has been set up to the same value, you will find out a couple of days later the machines will show you different dates and times. So not all the clocks in the world, even if you set at a CMOS level, would follow the same date and time. It's very normal that there might be a clock drift. So those two machines, if they have a problem as far as the clock time is concerned, one machine says for me today it is so and so date 10:09 a.m. and the other machine says I am at 11:09 a.m. You will experience certain problems in the clusters. So certain time drift is allowed, but not beyond that certain limit. That certain limit most often is 13 seconds. If that drift is more than 13 seconds, you can anticipate some weird issues on your cluster. So your cluster may not have the documented behavior in that case. So it's often mandatory that those two machines which are participating as clustered nodes should be brought into a time sync, where both of them at any given point in time should show you the same day, date and time. There shouldn't be a time drift beyond 13 seconds. Now forget about 13 seconds. If you set up NTP, which is network time protocol, those machines will always show you the same day, date and time. The idea is, on the internet there are NTP servers. Their job is to work as the world clock. So they are the one like a GMT or that UTC. These servers will work as if they are GMT or UTC clocks. Rest of the world would align their time consulting the time on the NTP server. So every time you want to say what time is it, you will never see your watch. Indeed you will see your watch, but your watch is considering the de facto standard as the NTP server's time. So periodically the servers in your network would contact the NTP server, and whatever time is suggested by NTP server, accordingly they would adjust their date and times. So if I am rushing forward, my clock will be neutralized. If I am lagging backwards, my clock would be forwarded or adjusted as per the NTP time. Now when this happens, in no case two machines referring to the same NTP server would have two different times. In no case. They will always show you the same time. So certainly there would be no time drift in that case. Clear? So skew will not be there. So your date and time will not be different than my date and time, provided we refer to the same internet NTP server. So often in real life, your Unix admins would set up your server's time as per the NTP server. So pick up some server to act as an NTP server. It could be any machine, and pick up all other machines as if they are NTP clients, and your NTP clients will adjust their date and time depending on the time available on the NTP server. Oracle, starting from 11G release 2, has introduced a new service called as CTSSD, which stands for Cluster Time Synchronization Service Daemon. Now it might so happen that you may or may not use NTP. NTP is the OS facility. It has nothing to do with Oracle. So you might time synchronize your clustered nodes by doing the necessary NTP setup, in which case the times for your clustered machines are synchronized using the OS provided mechanism, the operating system supported mechanism. In another case, starting from 11G release 2, NTP is not mandatory. Although Oracle cluster checks that whether or not NTP is there, and if NTP has not been set up, it will also complain about it. But then, as I said, NTP is no longer mandatory. Oracle from 11G release 2 has introduced its own daemon, which is CTSSD daemon, cluster time synchronization service daemon, which can help you synchronize the machine's time if a time skew is detected between the clustered nodes. So it has a capability of synchronizing the machine's time. That's why the daemon runs as root user, because machine's time cannot be changed by any Tom, Dick and Harry. I mean, as an unprivileged user. You need to be a privileged user to be able to change the machine's clock time. Now, since Oracle has its own mechanism, you may or may not use NTP. I'm not saying that NTP need not be used. They are mutually exclusive. You might still use NTP, but CTSSD will still be there. You may not use NTP and CTSSD will still be there. The only change in the behavior is CTSSD, in case of NTP based implementation, works in observer mode. So CTSSD is anyways mandatory, as I said. The only difference I said is, if you use NTP as the OS supported mechanism for time synchronization, CTSSD will still be there, although it will only act as an observer, because NTP is doing the necessary time sync. However, if you don't implement NTP, then CTSSD will be there in a master mode. In a master mode, it can take charge and change the machine's time if your machine is lagging, or if it has scrolled a little forward. It can bring it, it can neutralize that time. In which case, you must be running that CTSSD program, the daemon, as a privileged account. That's why if you see at a OS level, after the cluster is installed, the cluster time synchronization service daemon would often run as root. Next is to establish SSH user equivalence. First, let's understand why it is required. Installer is invoked only on one node. So irrespective of the number of nodes in your cluster, OUI, the Oracle Universal Installer, needs to be invoked on any one machine from the available lot. So I assume that I am planning to go for a 3-node cluster, alpha, beta and gamma being the nodes. I could select any one node where I would launch the installer. Automatically the software will be copied to the remaining nodes. It applies for grid infrastructure software, and it also applies for the Oracle RDBMS server software. So installer is invoked only on one node, the OUI would copy the software to all other nodes in your cluster configuration. Now, to be able to do this, you invoke the installer on one node as Oracle user. Let's say I logged in at Oracle on Alpha and then I started OUI, the run installer. Now the installer would ask me at some point in time, tell me which all nodes you want to plan to configure in cluster. I said the other two nodes are beta and gamma. I would provide the necessary node details. You will come to know once we go to the installation. And the installer would automatically propagate that software to beta and to gamma. So you need to copy the software as Oracle user on alpha to Oracle user on beta to Oracle user on gamma. Now first of all, to be able to do this, your Oracle user on beta, your Oracle user on gamma must trust the Oracle user on alpha. If they don't trust each other, it will not allow you to copy the software. It will prompt you for the password. And there are several hundreds of files that needs to be copied. And you don't certainly want to be bugged by that password prompt saying provide me the password for Oracle on alpha, Oracle on beta, provide me the password for Oracle on gamma. Every time you copy one file from the node where you have invoked that installer to the node where you are copying it. Clear? So the installer is invoked only on one node. Let's call that node as a primordial node, the first node where you invoke it. Software will be automatically copied to non-primordial nodes. And to be able to do this, the user accounts on non-primordial nodes must trust the user on the primordial node. So there must be a trust relationship. For this, you must establish SSH user equivalence. It's very simple. It's like the old Bollywood movie. Each machine will have a public and a private encryption key. And when they talk to each other, they would exchange their public keys. And the public key will be checked with the private key equivalent of that node. If that matches, that means you are a trusted party. So assume like you are that old Bollywood movie smuggler. You are there to get the consignment. He will give you half the note, a code word, and he will say code word is red rose. Oh, you are the trusted party now. Or you will be given a 100 rupee torn note. One half will be with that smuggler, one would be with the consignee. You need to match. If that note is mapping, that means you are a trusted party. I watched a lot of Don movies. So they must have picked it up from Bollywood movies. So I am going to generate my identity first. The first thing is generate the public and private keys for Oracle user on alpha and beta. See what I am going to do now. Here I am on to alpha. I am logging in as Oracle user. Here I am on to beta. I am logging in as Oracle user here as well. The first thing is I would generate my keys. SSH keygen -t RSA. RSA is the encryption standard. You can select either RSA or DSA. For every question, just press enter. Now what has happened because of this command? In your home directory, it has generated one hidden folder .ssh, and within that hidden folder there is a public RSA encryption key and the private key. That ID underscore RSA is a private key, ID underscore RSA.pub is a public key. Same thing must have happened on beta as well. Clear? Now you need to exchange the public keys. Now before I exchange the public key, see what happens. What if I do not exchange? I said, remember I am Oracle user on alpha here. I said connect to Oracle user on SL beta and show me the output of hostname command. It says, are you sure? I said yes. It says type the password. It says type the password. Only if I type the password, it shows me the command's output. So that means Oracle user on beta is not trusting the Oracle user on alpha. That's why it is prompting for a password. Same thing, Oracle user on alpha does not trust the Oracle user on alpha itself. See here. So even the Oracle user to Oracle user on alpha, they do not trust each other, meaning across different sessions. Now to facilitate this trust, you must exchange the public keys. Now see what I am going to do with the public keys. I copy the public key as one line. No more, no less. This is most commonly committed mistake, that people unnecessarily copy it to beyond that last alphabet. Then paste it in your temporarily in a location, say notepad location. Ensure that it's only one line, no extra characters. Similar way, copy the public key of beta. No extra characters to be copied. Paste it in a notepad to ensure that it's a single line. Once that has been done, go to alpha in the same folder, that is .ssh, create a new file called as authorized underscore keys and paste both the keys there. Ensure that you have only two lines. See here, although the lines might sound like they have wrapped, but line count I have enabled line numbers, you have only two lines. Do the same thing on beta. Create a file called as authorized underscore keys and paste those same two lines there. Now let's try doing a connection by saying Oracle at SL beta host name. It's no longer prompting me for a password because now they trust each other. I said SSH Oracle at the rate SL alpha. It's no longer prompting me for a password. It's trusting now. You must do a reverse test as well. I am on Oracle user on beta. The first time warning must be removed, else the clusterware will detect this as a problem. So now see, no more passwords being prompted. Try to connect in to this warning must be removed. See here, no password being prompted. So establish necessary user equivalence. Copy the contents of your public key file to authorized keys file under $home.ssh. And test your passwordless setup using four-way connection. Oracle on alpha to Oracle on alpha, Oracle on alpha to Oracle on beta, Oracle on beta to Oracle on beta, Oracle on beta to Oracle on alpha. So test it using all four ways. Only then your installer will not complain. If you do only one type of a test, that warning message you see for the first time connection, it shows you the warning message. Even if that warning is there, Oracle will treat this as if SSH user equivalence has not been set up properly. Very important now. Now comes the storage part. Set up your host as an iSCSI initiator and log into iSCSI targets. Remember, we have a NetApp filer SAN setup, although I have not started it. I am doing it now. First, very important thing, extremely important. You must not start up the NetApp filer simulator in PuTTY. You must not. You should start it either in VNC or in the GUI console, wherever, but certainly not in PuTTY. Now, what is the problem in PuTTY? Accidentally you might close PuTTY and the program will crash. Clear? So do not run it in PuTTY. I am connecting to my DNS server where I have installed my NetApp filer software. I would start a VNC session. Once done, I will log into the VNC. And here I would run the NetApp simulator. Now even if I close this window, the VNC session will still be there. So next time, even if I close it accidentally, I can always connect back and my NetApp filer is still running. The same thing does not apply to PuTTY. This is to ensure my NetApp filer SAN is up and running. Next is, remember we have done LUN creation and LUN masking on the NetApp filer. I am logging in. I said LUN show. So you can see all the LUNs are mapped. Clear? Now they were mapped to some iSCSI IDs. I need to ensure, I need to take those same iSCSI IDs and create my initiator names accordingly. So I am going to NetApp filer because I don't remember what iSCSI IDs I used. Remember the IP address of my NetApp filer is .100 and for everybody for that matter. I am logging in as root welcome 1. I would go to the filer view. I go to LUNs, initiator groups, manage. And these are the IQNs that I am worried about. So I ensured what are the IQNs with which IQNs of my iSCSI initiators with which those LUNs are mapped. I obtain that list. Now see what I am going to do with these IQNs. I don't need this any longer. My job with NetApp filer simulator is done. Now I go to alpha as root and I edit a file called as etc iSCSI initiator name.iSCSI. Now see what I am doing with this file. See what is my initiator name as of now? Something else. But LUNs are masked with these IDs. So I will copy the ID of alpha and will paste it here. So now the IQN's identity for alpha is iqn.2012-11.com.oracle-expert:sl-alpha is now my IQN identity. Save this. Do the same thing for beta. Here I am on to beta as root and I edit the file again. I am not interested in the current IQN. Instead, I want the IQN for beta to be this. Done. Now once this is done, your iSCSI service is already started during the operating system startup with the old ID that was there in the file. So you must restart the service ideally. So I am checking service iSCSI status. It says it's already running. That means it is running considering my old IQN number. Since I changed it in the configuration file, I must restart the service. I am saying service iSCSI restart. Now the good thing is it will pick up my new identity. Clear? Now this is not sufficient. That doesn't mean I can see the LUNs now. How do I know that those LUNs are still not visible? I am saying ls-csi. I don't see those LUNs. The only disk I see is the one that I have created at the time of machine creation. The virtual machine disk of 80 GB. Nothing more. So I don't see those LUNs. The first thing you need to do is to discover the iSCSI target. iSCSI target is nothing but your NetApp. See what you need to do. I am using a command called as iSCSI-adm man page of it. I am going to down under to find out the help of iSCSI-adm. Discover targets at a given IP address is what we need to do. To do this, I would use this command. The small change. Instead of this, I would put the IP address of my NetApp filer. See, understand what is the purpose of this command. As of now, your client does not know the IQN identity of your target. But you know one thing for sure, where is the target? At which IP address? It is at the IP address 172.168.200.100 is where your NetApp filer is running as a iSCSI target. So you are discovering by going to that IP, you are asking a question. Tell me what is your IQN number? So I am asking this question now. So here I am on alpha. It says my IQN number is this. Where from came that answer? The answer came from NetApp filer. I am doing the same thing on beta. In any ways, the IQN number will still be same because finally they are connecting to the NetApp filer and asking the whosoever is available at this IP address saying tell me what is your IQN identity. Once you know the IQN identity, copy this. Again use iSCSI-adm command, this time however with a different option, that is to log in to the target. And to log in, I am using pretty much the same thing, a small change. Now you got the IQN ID. Use the IQN ID to log into the target. Also check that you are using the correct IP address. So see what this command is doing. iSCSI ADM mode equal to node, target name equal to. This is nothing but the IQN number of your target which was obtained from the previous command. Portal equal to the IP address where your NetApp filer is running. Run this command and see what happens immediately. As of now, I don't see those LUNs. I'm duplicating this session. I'm doing a tell-f of var log messages. And now I am running the command. See what happened. It says logging to iSCSI initiator using TCP protocol. Vendor is NetApp. Model is LUN. Revision is whatsoever. Direct access, which is block access, I said. SDB as a new device of 3 GB has been detected. SDC, SDD, SDE are the devices that are being detected. How do I know? I said lscsi. Now you see those LUNs. Clear? All the LUNs are discovered now. Do the same thing from beta as well. Prior to running this command, I am saying lscsi. Now I run the command. Still I am not able to get it. Did I not restarted the service here? Remember, since I never restarted, it was using the old IQN number in the file. Since I didn't restart it, the LUNs were not visible because IQN number is not matching to the mapped IQNs on the NetApp filer. The moment I restarted, it picked up my new identity from the iSCSI initiator file and it reattempted. Now I can see all those disks. Remember, these are like disks. I say fdisk-l. This is my first disk, SDA, where you have installed your operating system, the swap partition and U002. Remaining are SDB, which does not have any partition. SDC, which does not have any partition. SDD, which does not have any partition. SDE, which does not have any partition. Remember, we created 4 LUNs of 3 GB each. All those 4 LUNs are now visible. Clear? Next thing is, I should have put it here actually. All these steps. Should have been here. Next is to install ASM lib software on your alpha and beta nodes. Relevance of it I will explain at a later stage, why you need ASM lib software. But certain important points about ASM lib software are: ASM lib software is kernel version specific, meaning I cannot download any ASM lib software and install it anywhere I want. The kernel version must match. So first thing is, what is my kernel version? The kernel version is this. So I must ideally install the same version software. The software is again available on the same Windows machine where other things are available. So I'm logging using remote desktop to the same machine where you eventually log in. On your desktop there is icon called as Oracle Software Linux. There's a folder called as ASM lib. Copy this whole folder to your Unix machine, and I need to copy it to both alpha and beta. Copied in the root's home directory, that's fine. Anyways, you need to be root to be able to do that installation. It's copied to alpha. Copied to beta. Now here I am as root. In my home directory there's a folder now, ASM lib. Install all the RPMs. Similar way do it on beta. Install all the RPMs. See here, the RPMs are kernel version specific. Very important. Now why I am stressing on this one? Not because of installation. Your kernel, we have seen here, is 2.6.18-164. The RPMs that you are installing are also of the same kernel version. So kernel version actually is 2.6.18. -164 is the errata update, the updates that you have applied to your operating system. If you try to install any other version ASM lib software, it will not work. This is not important. The important part is, that means every time your operating system guys do a kernel update, your ASM will not work. This is very important. So if they apply a OS patch and the kernel version changes from something like 2.6.18-180, your ASM is gone. Your ASM will not work. How long? Until you download the latest version of ASM and apply it. OS team would often not do this. So every time they do a patching, they give me a gift. ASM not working gift. So very important. So be very wary about this particular requirement. Install the ASM lib software. And install all those packages. Very important. Let's understand first what we have done. We have installed the ASM lib software. Okay, what it has done, what great things it has done. It has provided you a script. This is a very important script. I am running it. It says the options are start, stop, restart, enable, disable, configure, create disk, delete disk, query disk, list disk, scan disk, status are the various options. So any ASM activity would be done using this script. The activity is starting the ASM lib software, configuring it uh, once, enabling it, disabling it during reboots, stopping it just because I want to troubleshoot something, creating a disk, deleting a disk, querying the disk, and scanning the disks. All these activities can be done using this provided shell script. This is a shell script, by the way. That allows you to do this. Clear? Now, after you install the ASM lib software, you must configure it once per machine. So every machine you need to run the configure option of this command. I am running it. I will also explain at a later stage what we did. This needs to be done once per machine. I am running it etc init.d oracle asm. It says, tell me who would be the owner. I said Oracle. Tell me what would be the group of Oracle. I said O install. Very important questions. I will explain the relevance at a later time. Do you want to automatically start the ASM library driver every time your machine boots? I said yes. It says, do you want to scan for the probable disk every time your ASM boots? I said yes. That's it. It asked me very nominal questions. Now the whatever I have answered here, the responses are stored in a file. etc sysconfig oracle asm. See, I said, do we need to load the ASM lib every time my machine boots? Yes. Which user? I said Oracle. To which group he belongs to? O install. Do you want to scan for the disk every time your ASM starts? I said yes. So all those responses are captured in this file. Now, every time I reboot my machine, the behavioral aspects are picked up from this file about ASM. Clear? Now, since I configured it, I check. See here, the Oracle ASM library module is automatically loaded. I try to do the same thing on beta. That is what is the importance of configure. You have just installed the software, but the software is not started. So to configure every time your machine reboots the auto start options, and to start it now itself, you need to run the configure option. So I'm running it now. So I checked ls mod. Ls mod means it shows the loaded modules. So ls mod should show you something like this. I'm going to run through the configure option one more time for beta. That's it. Now I am saying ls mod. See, the module is loaded. I need not worry about reboots now. Every time my machine reboots, the module will be automatically loaded because I have given those options in the config file. The config file is this. etc sysconfig oracle asm. Clear? Now the software is installed. The software is configured for auto load every time. However, I do not have ASM disks. ASM disks are not there so far for creating ASM configuration. So the next discussion is about provisioning ASM disks. Understand what do we mean by provisioning first. Provisioning a disk means stamping it with some Oracle specific disk header and thus reserving it for ASM use. So what Oracle does as part of the process, as part of the provisioning, it goes and writes some information in that disk header. Which disk? That I am going to tell. So the next thing is, I want to do this for each of the disk LUNs that you have created. So we have 4 LUNs discovered on alpha and on beta as slash dev slash sdb slash dev slash sdc slash dev slash sdd and slash dev slash sde. These are the 4 LUNs that are discovered. Now to be able to stamp them, you must zero format them. Zero format them means you must erase whatever is available on those LUNs. You must erase all those disks. Now I know for sure the LUNs that I created came from freshly procured shining disk, isn't it? The disk was shining. I never reused any of the existing disks. Remember, your NetApp has LUNs which are created from 25 shining disks. They were never used. So I need not actually rewrite and erase it with zeros. But you never know, the LUNs that you will be getting, they might be reusable disks. Those LUNs might already contain some garbage data. Now on such LUNs, which is a logical disk, which was earlier being used for some other application on some other machine, it might still hold some data. And to be able to write that disk header, which will not be then comprehended by Oracle, the best thing is to do is to overwrite those disks with 0. Clear? In my case, it's not required because I have got freshly procured factory manufactured disk. I just went prior to the class, purchased those disks and attached it. They are shining. You never know in real life whether those LUNs, the ones that you are getting, are from a freshly procured disk or those LUNs are being reused. So in which case, the best part is to overwrite those disks. So as many disks as you have to zero format them. Now what is the size of a LUN? How many such LUNs are there? So if I start writing zeros on those 12 GB disks, next session will be on next Sunday. By that time I would have formatted them. Remember, we are using a copper wire connectivity between alpha and the NetApp. Writing 12 GB of a data on a 100 MB wire is not a feasible solution here, isn't it? In real life you don't care because those LUNs would be connected to your server using a FCHBA, which can write data at 8 Gbps. So you are not worried in a real life case. I am quite worried here because I don't want to write 12 GB of a data on a 100 Mbps network. So I am not going to follow this method. Instead, I will follow another method. The otherwise is, if you do not want to overwrite those disks, create one partition on that entire LUN. I am going to do this because this doesn't take much time. So see what I am going to do now. Fdisk slash dev slash sdb. I am saying P to print the partition table. There is no partition. I said N. P for primary partition. Partition number 1. Starting cylinder, ending cylinder. Print. Now you see there's one partition. W to save and quit. Clear? This way I will create partitions on SDB, SDC, SDD, SDE. See one more time. I said SDC P to print the partition table. There is no partition as of now. N to create a new partition. Now the available choices are extended or primary. I am saying P for a primary partition. I can create at the max 4 partitions per disk. As of now there is no partition. It says tell me 1 to 4 which partition. Certainly 1. It says give me the starting cylinder. I said whatever is the default. It says give me the ending cylinder. I said whatever cylinder number is possible. I say P to print the partition table. Now there is another device called as dev SDC1. W to save and quit. On the similar lines, I am going to do it for SDD and SDE. New, primary, 1, starting, ending, save and quit. New partition, primary partition, first partition, starting cylinder, ending cylinder, save and quit. So I created one partition each on those LUNs that we have. Is that clear? Now I am saying fdisk-l. See here, earlier SDB said the disk was not partitioned. SDC said the disk was not partitioned. SDD said the disk was not partitioned. SDE said the disk was not partitioned. Now there is one partition each on those 4 discovered LUNs. The same LUNs are visible on beta. Agreed or not? So do I need to create the partitions there? Let's validate. I said fdisk-l. All those partitions are pretty much visible here because finally the disks are shared. Clear? Now one common thing. Now I want to see the device names. So I see the device is SDB, the partition is SDB1. The device is SDC, the partition is SDC1. The device is SDD, the partition is SDD1. The device is SDE, the partition is SDE1. Now let's see the same thing on beta. Partition तो दिख रहे थे आपको, डिवाइस नहीं दिख रहे क्योंकि फॉर्मेटिंग का प्रोसेस आपने कहां से किया है, पार्टीशनिंग का प्रोसेस कहां से किया है, फ्रॉम अल्फा. Those devices are not readily visible on beta until I reboot beta. Instead, from beta, I would say part probe /dev/sdb2e. Part probe say it revisits those disks to find out what are the partitions created on it. Now all the devices are visible. Alternative would have been to reboot it. So create partitions on each of them from SDB, on SDC, on SDD, on SDE. Remember what we did? P to print the partition table, N to new partition, P for primary, 1 partition number, starting and ending cylinder, P to print the partition table, save and quit. Clear? So now the disks are visible. The disks are now in a usable state. So the disks are there. Next thing is to provision an ASM disk. To provision an ASM disk, I am saying etc init.d oracle ASM create a disk /dev/sdb1 ASM disk 1. Sorry, ulta. So what I said, go to this disk and write this name in the header of that disk. This is what is called as stamping. How do I know whether it has really stamped? I will explain at a later stage. Similar way, disk 2 which is for the device SDC1, disk 3 which is for the device SDD1, device 4 for SDE1. So I created these many disks. So stamp those disks. Now are they really available? I said LIST See, all these disks are created. Now let me check the same thing on beta. Are these disks visible on beta? No. So part probe was for partition probing. So it has one option called as scan disks. So you have to just rescan them from beta. So I am saying scan disk. Hold on before I run. I will anyways eventually run this. Now see what happens when you create a disk. I am going to a folder called as dev Oracle ASM disks on alpha. Couple of very important observations. What is ASM disk 1? Very important observation. Now focus. These are my actual disks owned by root. They are all block devices. Right? These are nothing but aliases. I said ASM1 is actually an alias for SDB1. ASM2 is actually an alias for SDC1. ASM disk 3 is an alias for SDD1. 4 is an alias for SDE1. How do I know? That is because check the major and minor disk numbers, major device numbers. These are called as major and minor device number. Major number is 8, minor number is 17. So SDB1 is associated with whom? That's why their device numbers, major and minor device numbers are matching. So if someone asks you, tell me if this is the device, which will be an ASM disk associated with this one? ASM disk 3, because their major and minor device numbers are matching. Clear? Very important thing. Who is the owner of these aliases? How come it knows that I want to do it with Oracle? Because during etc init.d Oracle ASM configure, it asks you who should be the owner, who should be the group owner. So whatever you provide there would be the owner of those disks here, because ultimately ASM will be running as which user? Oracle, not as root. So if I consider these disks, the problem with this disk is onto those disks you cannot write as Oracle. See here the permissions. So people say, why don't you change the permission? Changing a permission is only applicable until I restart my machine. Once I restart my machine, the device tree is again recreated. The permissions will again go back to root disk. That's why you need ASM lib. ASM lib is used for SCSI persistence. This is used for SCSI persistence. So what it did when you say create disk ASM disk1 / dev / SDB1, it actually went to the disk and in the header it has written some name. See how we do that. I said strings -a and I will say more, or let it go through. देखो उसने उसके हेडर में क्या लिखा है? ORCL disk ASM disk 1. This is what I said is the process of stamping. The process of stamping goes to the disk. In the header it writes some Oracle specific entry, and this is how Oracle ASM will be able to identify that this disk seems to be an Oracle disk. Clear? If you see, the same thing is not there on beta because those disks are not yet identified on beta. So I go to dev Oracle ASM disks and I say ls-la. No disk is there as of now because Oracle ASM Lib software was started earlier. Later on, those disks were created. If I reboot my machine, those disks will be visible. But I am saying there is no need for reboot. Instead, you can say scan disks. Now say ls-l. See, all those disk devices are available. Now I say list disks. All those disk devices are available. Very important. Now you are all set up with the ASM disks. So ASM disks are all ready. You can query them on alpha, you can query them on beta.